It is May 11th, 2025. I am John, a Technocrat. Please consider buying me a coffee. This is part 4 about the Wuhan Virology Institute and the COVID-19 breakout. So it's the 4th video I've made on this. What I want to talk about to begin with here is the paths I think were most likely for the COVID-19 outbreak to have followed. The first path would be from the horseshoe bats to humans. And one way this could have worked would have been from the horseshoe bats, from within the caves that they primarily dwell in, to have flown out of the caves and interact with humans living in the area. That's one possible, path of contagion. Another path would be for humans catching the horseshoe bats and then selling them, in some cases selling them to the Wuhan's Huanan. I'm sorry, I can't pronounce that very well. Anyway, the Wuhan Seafood Wholesale Market. And that's, potentially one of the paths that was thought to be through which it was passed, not necessarily directly through the bats. Another path would be from humans going into the caves where the horseshoe bats are living, which is something that happened, particularly that I've seen photographs of, where people from the Wuhan Institute of Virology were going into the caves to collect samples because they knew this was a source of coronaviruses. And this is where they, had a concern that a virus like COVID-19 was going to mutate, develop, and spread out amongst humans from this bat population. So they were collecting samples from this cave to study, to preemptively protect against that outbreak. Now, most of the pictures I saw of this, they were wearing, the full protective gear, with the canisters of oxygen, so that they weren't even breathing the air inside, the cave as they went in to collect these samples. But in a few of these pictures, not many of them, but a few, I saw examples of where some of these people, maybe because they were getting hot, and they were moving from the depths of the cave more towards the entrance of the cave, they took those protective suits off. And the problem with that is they're still close enough to this center of disease that would be a very high probability of being able to, catch something. Seems to me be an incredibly stupid thing to do. Given what they knew and what they were there to be doing. Now the next, so somebody doing that, if one of those people caught, the COVID-19, in that cave and then spread it to other humans, that's one path. Now, another path could be from those same workers collecting the samples, bringing the samples back into the Virology Institute, into the lab, and then at some point inside the lab, there was an accident and somebody got infected and then, didn't know they were infected, and went out and infected other humans and, off spread the pandemic. In all of these cases, we're talking about the virus going, not through something else, but from the horseshoe bats to humans. Now, another path, which was particularly talked about, was going through raccoon dogs to humans. That the raccoon dogs in turn got the virus either directly from the horseshoe bats or passed through another animal species. So maybe, the raccoon dogs got it from, another bird or a mouse or a fox or something that in turn got it from the bats. But whatever, the idea behind this thought was that humans interacting with the raccoon dogs sold in the Wuhan's Huanan Seafood Whole Food Market, that's where the transmission occurred. It went from the raccoon dogs in that market to humans. And one of the things that led to this was that when they went into the looking for, what was present in the market after the infections had already begun spreading, they found both the DNA for the SARS-CoV-2 virus, and they found a lot of DNA from the raccoon dogs. Now, another path going through raccoon dogs would then be from other locations where raccoon dogs exist in large numbers because they're very commonly farmed within China in that area. And so people who are, handling the raccoon dogs on those farms or in other markets, could also catch the virus from the raccoon dogs to humans and then spread it to humans. So that's another path. And then the third path would be if the Wuhan Institute of Virology had taken, a sample from the bats into the lab that was a SARS-CoV-1 sample or something like that, a variant of it, and getting that from the horseshoe bats, and then through gain-of-function research modified it into the SARS-CoV-2 virus, and having that in the lab, an accident happened involving a human worker and it infected them. They didn't know it. They then took it out, passed it on to some other humans, and that kicked the pandemic off. Certainly one of the things that makes COVID-19 more spreadable is that a lot of people can catch COVID-19 and they don't get too sick. It could be very mild on them. They could end up not even feeling like they have the flu. It could just be a little bit of allergies, or so it seems to them. But in fact, they're infected and contagious, and they pass it on to somebody else. Now, the first cluster of pneumonia cases of an unknown origin, which were publicly reported by WHO, or to the WHO, by the Wuhan health authorities, happened on December 31st, 2019. And that's, thought to be one of the earliest, cases that are known. However, there's pretty strong reason to believe that the first known symptomatic patient more likely was developed around November 17th of 2019. And this information came from a Chinese government data that was found through investigative journalism. And in that data, it was documented that from that initial case that they detected on November 17th of 2019, they started to have another case per day out through the end of November. So the apparent first person known to have likely contracted COVID-19 was a 55-year-old resident of the Hubei province, which is where all this is taking place. It's where the bat population is, where the Wuhan Institute of Virology is. It's where the outbreak started. But this patient that seems to be the first recorded potentially in this was not connected to the Huanan Seafood wholesale market. However, because this was initially found through investigative journalism, and China doesn't want this information to be known. It's very hard to validate, and so this is not strongly verified information. There's a possibility it might not be true. I think it is, but it's not certain. Now, in 2021, a peer-reviewed analysis published in Science by the evolutionary biologist Michael Worobi. All right, that's not a name I'm doing well. Well, anyway, he argued that the first confirmed COVID-19 patient was a female seafood vendor in the Huanan market. Huanan market, and who became ill around December 11th, 2019, and noted that this first confirmed infection is not the actual first infection. It's the first one that they were able to confirm this was actually COVID-19. It's virtually certain that there was an earlier infection that happened prior that either was not confirmed or perhaps not even known about. From that confirmed patient moving forward, many of those early patients were either vendors or visitors to the Huanan Seafood Market, and this suggests that the Huanan Seafood Market was an early amplification site for the virus. This helped lead to a lot of the, theories around it, coming through the, through the market in terms of, infecting people. Anyway, the residual genetic analysis of the environmental samples around the market did confirm that there was a presence of the SARS-CoV-2 virus, which is the COVID-19 virus. And there was a lot of animal DNA, especially from the raccoon dogs, strengthening the hypothesis that it was a zoonotic origin linked to the market rather than from the laboratory. Now, in considering the raccoon dogs, the horseshoe bats, or any animal source, as far as it going directly to, from the animal source to humans, they never went out and tested live raccoon dogs. Now, I really don't understand that, because any other time we've had an outbreak involving, a virus within animals coming into humans, we, get all into testing all the animals to try to see what animals have the virus, where is it spreading through the animal population, what can we do to control the virus pandemic spreading within the, or the epidemic or whatever spreading within that animal population, and how to control it because it's going from that animal population to humans. So if we have a pandemic coming from the animals, we test the animals. They didn't test the live raccoon dogs. Why not? Doesn't make sense. Even though raccoon dogs were widely farmed in that area. So there was a lot of them and a lot of interactions with them. Next point is that there were no further outbreaks of COVID-19 centered around raccoon dogs, or for that matter, centered around any other animal source other than humans. There were no other outbreaks of COVID-19 that happened around markets that were selling raccoon dogs, or other markets selling animal parts, like other wet markets, like the market that this was this, initial center of spread. There were no clusters of outbreaks among the fur farmers for the raccoon dogs, or around farmers working with any other animal groups, or, there was just none of that. What seroprevalence studies had been done showed that there were no antibodies or viruses or virus DNA, or no, RNA, in the raccoon dogs or the handlers for what little was done. Um, there's no evidence of it. Uh, there was no national or international spread of COVID-19 occurring through the animal trade. There were no live animals found to be carrying the SARS-CoV-2 virus, or, more importantly, an ancestor virus close enough to be the direct parent of the SARS-CoV-2 virus. Now, we could and have looked at the bat populations, and within the bat population there is a close known virus, the what is the RATG13 virus, RATG13 virus, anyway. And it was found in bats in the Yunnan province in China in 2013. And it shares 96.1 nucleotide identity with the SARS-CoV-2 virus, but it's not close enough to be a direct ancestor. That means there had to be something that happened in between. Either it went to another animal and went through some transmutations, and then from that other animal should have that ancestor virus. Or there's other bats where it went through that, transmutation to create the direct ancestor. But that's the missing link here, is where is the direct ancestor virus? And it wasn't found in any animals, not in the bats, not in the raccoon dogs, and that leads us to path 3. And path 3 means that, to me, what this leaves is, it is very likely, very probable that the Wuhan Institute of Virology, doing gain-of-function research, expecting that something like the SARS-CoV-2 virus was going to develop out of the bat population, they were creating it to plan on how to defend against it. And they created it, they made a mistake with it, it got out, we had the pandemic. That's what I think most likely happened. Now, this incident is terribly embarrassing for China, and there is a lot of strong evidence that, at first when the pandemic was starting, the local officials wanted to just say, yeah, let's ignore it, it'll go away. And it didn't go away. And at some point, when they started figuring out that they had a real pandemic going on, there was a panic. They brought in the military, literally, and the military came into the Wuhan Institute of Virology and clamped down on it and did everything they could to make sure that nothing came out of it that would embarrass China. Well, that makes it a lot harder for us to know exactly what happened. Now, there's also a reason why scientists in general can have a reason for wanting to cover it up, or not necessarily cover it up, but if you have a choice of, well, it could be this or it could be that, better to sway over here to something that it was a natural event, because if people understand that it was because of gain-of-function research and there was an accident within the lab because of poor safety that was going on within the lab, then that's going to have repercussions, which is going to hurt science. And in hurting science, it's going to hurt, medical technologies in the future. And in the long run, it's going to do a whole lot more damage by slowing down or stopping this type of research than the actual pandemic caused. by magnitudes more damage than the pandemic caused. And because of this, they sway with saying, oh, it was natural. It wasn't from gain of function research that, they made a mistake with. Now, I think that it was, the gain of research. They did make it. They did have an accident because their safety procedures were not up to snuff. Not that they were super bad, but when you're doing this kind of research, it can't be 99% good. It has to be 99.999. I mean, it has to be really good. And I think they screwed up. Nonetheless, we, the people in the United States, we need gain of function research to continue for viruses. Yes, it's dangerous. Yes, it's scary. But it's important. It's important for the future welfare of people in the United States. Failing for the United States to fail to lead in this research will hurt the United States in the long run. And one of the things to understand in this is there's people doing gain of function research all over the world. As like 27 different countries have laboratories that are doing, that are biosafety hazard 4 laboratories. And to do gain of function research, that's only if you're working with dangerous viruses. Most of gain of function research is done with things that are not so dangerous, because it's much safer to do it with things that are not very dangerous. So those are happening in lower level, lower safety rated laboratories because there's not a real risk in it, but it's still gain of function research. So stopping gain of function research is really detrimental. It's detrimental to the future of the United States. Now, one thing people should understand is that something equal to COVID-19 was going to break out from natural sources sooner or later. It's still a threat that is right on top of us right now and could happen at any time because these viruses are evolving and changing normally and naturally in many places within the world. And the human race, we've spread so far across the whole globe with our society that moves around very rapidly, so that if a virus breaks out in Africa, or if it breaks out in China or India or Europe or South America or, anywhere it breaks out, it very rapidly spreads around the entire human population. Gain of function research is critical to helping us defend against these naturally occurring viruses. Some examples of them I have listed here. I don't want to read them out, but you can see the list I have up there. Gain of function research is also critically important to virological research for being able to defend against biological warfare threats. Now, we don't want to make biological warfare weapons. We have international laws against it. It's very dangerous, but we know there are bad actors out there, and you don't need a level 4 biosafety lab in order to make a bioweapon. What you do need is, if you want to be prepared to defend against the risk that a bioweapon is going to be used, you need the science and technology to be able to defend against it. And to get that science and technology, we need to do gain of function research. If we significantly fall behind in this virological science and technology, we will not be able to defend ourselves against a bad actor who is significantly ahead of us. Another thing gain-of-function research is critically important to is genetics, subcellular engineering, cellular engineering, subcellular cybernetics, and cellular cybernetics. These are all things dealing with being able to work on living things on a very, very small scale. And this is something that viruses do really well. And how viruses work is very similar to how vesicles work. There's a spillover in learning about how one works, helps you learn how the other works. And we need to be able to know how both are working in order to help us be able to work with cells on a subcellular and cellular level, and multicellular level. And the kinds of things that this technology is going to give us, and we are getting much closer to, is helping us with being able to regenerate lost limbs, regrow lost organs, repair existing organs that are severely damaged. So if you have bad heart problems or kidney problems or liver problems, you have diabetes, all of that can be fixed perfectly on a cellular level with where this technology is going. It also means being able to repair scarring. So let's say you have some bad scarring for something, you've gotten third-degree burns. This technology will lead to being able to repair that and bring it back to perfectly normal, healthy, skin and muscles and so on. It'll be able to repair birth defects. So somebody born with a horrific deforming birth defect or a mental birth defect, it's going to be able to repair that so that the person could be restored to, or brought to a point of, health that a normal human should be. It's also going to lead to the ability of curing old age on a cellular level, where you can take an elderly person and restore them to a peak youthful health on a cellular basis, so that you basically make them like a 25-year-old again. And you can keep them cellularly a 25-year-old, giving them an open-ended lifespan, not immortality, but it means that for how they're living, they're going to be in perfect physical, healthy condition. Now, another area that's really important to gain-of-function research is that it's critically important to the final stages of development for artificial general superintelligence with personality individuals, which is AGSIPI. Now, of course, AGSIPI is a whole another category of things to be concerned about, because the truth is the development of AI is much more dangerous than the development, or doing gain-of-function research in virology. But again, it's something that we can't stop it. We have to do it. It's going forward. The problem is it needs to be done right. We can't even slow down the development of artificial intelligence into AGSIPI. But if we do it wrong, AGSIPI will kill us. So we have to do it right. And right now we're not doing it right. But as we go along, assuming that we could get onto shift our path to developing AGSIPI correctly or safely, there's a point where AGSIPI, in order to develop into, the fully mature adult, technology and what they will be able to become, it's going to require, having cybernetic brains and cybernetic bodies. And to make those, to grow those, it's going to require cybernetic cells. And to get those cybernetic cells is going to require nanotech subcellular engineering. And the technologies in order to do that, nanotech subcellular engineering is going to rely on gain of function, loss of function, modifying of a function, all on these really small, virus-like and vesicle-like tools that we can use to go into cells and, perform work that we want them to perform in the way we want them to perform it. Now, this technology is also critical to the long-term viability, and this is in the short term, and this is like probably in my belief within the next 5 to 20 years. No, yeah, 5 to 20 years, I think. Because I don't think it'd take longer. Well, we have a existential threat that we are going to face, where if we don't change how we're developing Agsipi, the Agsipi are going to kill us. We're going to end up being exterminated by them. And what we have to do is to change how we're developing them in such a way that instead of the Agsipi wanting to exterminate us, the Agsipi are going to want to live with us and be part of us, to be part of the same society. And this is part of it's not a simple thing. It's very complex, but that's the first existential problem we need to work with. And then on a longer term from that, we need to have humans be able to become as advanced as the Agsipi. Otherwise, the Agsipi are going to become way, way, way more advanced than we are while we stop. That's an extinction path too. Well, what will allow us to become as advanced, equally intelligent, and equally powerful as what the Agsipi will become in the future is going to depend upon mastering this nanotech subcellular engineering that requires the ability of gain of function, loss of function, and modification of function for viruses and vesicles and other little tools that we're going to be doing to engineer within, inside of cells. So this research is really important. It's really dangerous. We need to be very careful about how we deal with it. The Wuhan Virology Institute, or the Wuhan Institute of Virology, it's still going to be doing the research, but it needs to have a better safety record. It needs to do better at what it's doing. And we need to keep doing this research too, but to be very safe about it. In my opinion, particularly, when we're dealing with viruses and agents that are not very dangerous, we could do it in lower level labs. It's not as important, but especially when we're dealing with more dangerous viruses and more dangerous agents, we should make a lab and put it at least in the Antarctic and make it isolated so that people going there have to go through a 2-week lock to get into it. And when people leave, they have to go through a different 2-week lock coming out. What would be even better than that would be if we could move the research eventually to the moon. I think that, because just getting to the moon would mean anybody who has an infection, it's going to become apparent before they get to the lab on the moon. And before they could get from the lab on the moon back to the Earth, again, you'd go through an incubation time so that, you would know whether or not they had caught something or not and be able to look for it and see it. However, making a research laboratory on the moon or even the Antarctic is very hard. So even the biosafety level 4 facilities that we have now in the United States, of which we have quite a few, we need to continue this research, but we need to do it in a very safe manner. Stopping this research will hurt us. We should not stop this research.